Okay, so we're going to clarify what set notation is here. I think I set it up there, but here's just to recall what it actually is. Set notation then is a way to describe a set of numbers. In our case, it's going to be for domain and range. So there's my signification. Here's the actual set notation. It's the fancy brackets you see on your computer. That's going to signify some set of answers. And again, depending on how the function looks, determines what the set actually is. So if it's discrete, like we talked about here, actual numbers and not all the values in between, it will be more numbers. So this can be any set of numbers that it is for that particular problem. Let's pretend our range is continuous though. So if it's continuous, we're going to use y to signify range, and we're going to use an inequality. So we're going to say something like, I don't know, our range is all the values greater than 2, because this is on the low side, so this is 2 is less than the values that we expect for our range. And then our values for our range is less than, let's pick another number like 10. Okay, so that says that it's all the values in between. So I mean, just to look at that, if we want to take a peek, let's say here's 2, here's 10. It would be not only all the whole numbers in between, but all those decimals and everything in between. So that's when we use the inequality set notation when it's continuous. And again, our domain was discrete, so we use actual numbers. So let's do that real quick for our snack machine. So our domain for a snack machine was all the buttons. And we could list all the buttons. I could sit there and list A1 and A2, A3, and do that all the way through all the letters and through 12, I think it was. But there's an easier way. Sometimes we can actually use common sense or words or phrases to kind of signify that. In this case, I'm just going to say all the buttons. That's going to be the easy way to describe this. And that's okay. Sometimes if you can describe it, it works just as good. So there's my set, possible domains, in that set brackets, all the buttons. Our range was small enough that we should be able to write those down, because that was all the snacks. So our snacks then was nacho cheese Doritos. I think we had Cool Ranch Doritos. Pretty sure we had barbecue chips. And I think pretzels was the other one that we were working with. We won't list all the snacks for the actual example, just the ones we were kind of working with. So there's our domain and range. Now we've got to decide, is the relation that we were talking about there, I think we already hinted it was a function, is that defined by the one defined by the snack machine, is that an example of a function? Well, it is. And to tell you why is that we're looking for, let's look back to that bad vending machine. If I enter any combination of these buttons, it should go to whatever I pick. I see it in the glass. I should get that exact snack out. And our vending machine did that. If I entered A1, I got nacho cheese Doritos. It didn't surprise me at all. We said if there was a bad vending machine, if I entered A1 and I didn't get the nacho cheese Doritos that I expected, well, then I got something else like a Snickers bar. We said that was a bad vending machine. Ours didn't do that. We didn't have that issue. So ours was a function. So that's good. But let's take a look at that with some actual numbers. Both of these are discrete functions. Or I guess I should say relations, because we're not 100% sure that they're functions yet. We have to verify that it's a function. That every output has exactly one input. All right, so looking at this, let's go ahead and do the first part of this. Let's define our domain and range for it. So again, let's use that set notation. Here's our domain. Use my fancy brackets. My domain then is all of the first coordinates, x values, that we're going to put in here. So it's going to be 1, 3, 5. And our range then is going to be all of the second coordinates, our outputs, our dependent variable. I have to toss that around a little bit, but it's going to be 2, 4, and 6. Okay, so now we've defined that. Now we're going to decide if this is a function or not. So what we're going to do is we're going to check. We're going to say, okay, if 1 goes to 2, every time I see 1, the input 1, it should always go to 2. If it goes to anything else, it's not a function. So I'm going to go to my next coordinate point in here, part of my relation. I'm going to say, okay, now I've got a 3. It goes to 4. Every time I put 3 in, I get a 4 out. So every time I see 3, it better go to 4. I can see it again, but when I see it again, it better go to 4. And then I'm going to see 5. And 5 needs to go to 6. All right, and that's all of the points I have. So if I kept looking, I would make sure that this didn't duplicate, that I didn't have a 1 go to another number or anything like that. But it's good. So this is actually a function. What we're checking is really the vertical line test that we mentioned above, which is a visual way to do it, but this is how you do it if you're actually looking at the values. And I'll show you in the next part of the video where you use the vertical line test visually. Okay, so let's take a look then at this relation here. So let's start by identifying our domain. And again, our domain is a set of the first values. So, and no repeats. I guess I should mark that off. There's no repeats in domains and ranges. Okay, so I'm only going to write 1 because there's 3 of them here for my domain, first values. I'm going to write it once. Okay, and then I'm going to go ahead and identify my range. And my range then is going to be all the second values, so 2, 3, 4. So there's 2, 3, and 4. Now just like we did before, I'm going to look at 1, and I know it goes to 2. So every time I press 1, I should always get 2 out of it. But my next coordinate point says if I press 1, sometimes I get 3. So now when I press 1, I don't know if I'm getting 2, or if I press 1, I don't know if I'm getting 3. So that's that bad vending machine, right? So that makes this not a function. Okay, so we're going to take a look at these graphs. We're going to do the same thing we did before. We're going to determine if each one's a function. We're going to state the domain. We're going to state the range. So A, B, C, A, B, C. Deciding if it's a function is really easy if you're looking at a graph. We're going to use that vertical line test, which means that you take any function, and the function here is drawn, looks like a line. We would call this one linear. We'll learn that later. And if we draw a straight line through it, anywhere on it, at any point, we can draw as many as we want. If it touches it once and once only, that's the same thing that we were just talking about a second ago. That means that every output, every range, has exactly one domain. So this passes. We can't draw a line anywhere on this particular line and not touch it only once. If we touch it twice, then that means it's not a function. So this one passes our vertical line test. It's the same thing as we did above, just visually. It's kind of nice, a little bit quicker and easier. So this is a function. So for the domain and range, because this is a solid line, it means that it's continuous. And if we look at most of the functions on our paper here, on our graphing section, they're all solid lines. So these are all continuous. And if we go back to that first example, notice that's a set of points. That relation or that relation and function that we did, those are their actual values. So those are discrete. So our domain and range should look different between them. So these continuous functions are going to have to use the inequality set notation. So let's start our set. So our domain then, and when we look at domain is the values of x that this function exists on. So here's our x coordinate. Maybe even I change that color a little bit. So here's our x axis is what I'm trying to say. So really what it's saying is, where can I go on this x-axis and still find this function? Can I go to any of these values out here, and if I input them, can I get a value on the actual function? Well, if we extend this function, because that's what the arrow says, it extends forever. So really I can keep picking these values, and there's always a point that will pop up on our function. So I like to say its domain is where the function exists from left to right. So I'm going to write that on here. And I'm going to put arrows from left to right. So that's what I'm looking for. Where can I find this function left and right? So can I keep picking values on this x-axis? And can I continue to find those points on this function? And where does that stop? And this particular function goes on forever. So realistically, it never stops. And if it never stops, that gives us a couple options of how to write that down. Okay, we can use the inequality set because we said that that's possible. You can never touch infinity, so that means that we can't include it. So if you remember inequalities, if we put a line underneath, that means it's included. We can't touch infinity. So this is going to go all the way to, I guess I can keep putting values here until I get to negative infinity. Okay, so the lowest value that I could ever input, but not ever touch because it's infinity, would be negative infinity. So I'm not going to put a line underneath because it's not included in my set. And then on the right side, this is going to continue forever until it's at positive infinity. And at positive infinity, I can never touch it, so I also will never include it. So my set could be listed like this. The domain for x is all the values from negative infinity to positive infinity. Well, when we say all the values from negative infinity to positive infinity, another way to say that is all real numbers, all the numbers that we deal with in algebra for us. Okay, so it's all real numbers. We can write it either way. So now we're going to look at the range. So let me change a color here for the range. I'll change it to a nice green. Range then is going to be, and I'll put range over here, is all the values where I can find on the function that exists up and down. So where can I go up and down on these values and find the function? Well, you'll guess that it's fairly similar to domain in this case. Everywhere I go on the range, I can put a value in, and I can find a point on that function. No matter if I go up or down, I can still find a point on that function. So this particular range, if you look at this arrow, it's going to the left forever, but it's also going up forever. And similarly said down here, it's going down forever, the same as it's going to the left forever. It's on an angle. Okay, so it's going to go to positive infinity and negative infinity. That it's never going to stop. So just like we did with the domain, we can list it two different ways. One, we can say the domain exists from negative infinity to positive infinity using our inequality notation. There's our set. Or, just like we did above, we can keep it simple and say it's all real numbers. Okay. Now we kind of have an idea what's going on. Let's see if we can check that vertical line test and write a couple more domains in ranges so you get the idea. So if we look at this particular test, I only need one line here. I'm going to draw my vertical line test to answer that first question A. And that vertical line touches this particular function once, twice, 3 times. It touches it more than once, which means it doesn't pass the VLT, does not pass the VLT, the vertical line test, which means that if I input this domain, and this domain's like -2, if I input that value there, I get a couple different outputs. I get this output of 1, 2, 3. That's an output. There's a point there. If I put in -2, sometimes I'm going to get -3, 4, 5, 6, it looks like. And 1, 2, 3, 4, 5, 6. I'm going to get -6. So if I put in -2 for my domain, I'm going to get 6 sometimes. Sometimes I'm going to get 3. And sometimes I'm going to get -6. So that's how we checked above. But again, simply said, it didn't pass the vertical line test. So not a function. All right. So let's do our domain and range again. All right, so for my domain, I'm going to look at it, and I'm going to look at the ending arrows. That's really kind of what's important here. If I've got arrows, I need to extend them. I always like to do the motion of extending so I kind of get that feeling of what it's doing. So if I'm looking at this, again, domain is how far left and right it exists. Where can I find that function? And this arrow is pointing to left. It means it's never going to stop. So that's really telling me that I'm going to go to negative infinity. And over here, this one's going to the right, and it's telling me that I'm going to go to positive infinity. So again, we can use that notation. Start with x because it's domain. I can't have infinity, so these should be not included signs, no equal sign underneath. So I'm going to put negative infinity here as my low value. It's going to go to negative infinity. I can find it over here. And it's going to go to positive infinity. I can find it over there. So I'm going to put positive infinity. Or, again, we can use a simple way of describing it as all real numbers. Either way would be fine. So let's talk about our range. So for our range then for this one, again, let's check. This arrow is continuing to the right forever, but it's still going up. It still has an up action to it. So it's going up to positive infinity. And this one, while it's going more left than down, it's still going down. And remember, range is telling us how far up and down I can find this function. Where does it exist? So it's going down forever. Again, I can use this inequality notation saying it's going down forever, not including. Y, that's our domain, our range, and it's going all the way up to positive infinity, or all real numbers. Either way is fine. So let's do one that doesn't have all real numbers as part of its domain. Let's do 8. Let's check real quick to see if it's a function. Pass, pass, pass only touches once on each of those tests that I did, and I can look around and see that there's not a spot I can draw it that it's not going to pass the test. So it does pass. It is a function. Okay, so now that's a function. Let's go ahead and do our domain and range. So our domain, again, how far left and right it goes. So this is going mostly up, but it is going out. So it's going to go to negative infinity. And this side does the same thing. It is mostly going up, but it is still going out. So this function will exist at positive infinity. So I'm going to cheat and do the easy way. That's not really cheating. It's actually probably smarter. I'm going to write all real numbers. Okay. Now our range is where it starts to get a little interesting here. This is not going to be all real numbers. And the reason I know that is I'm looking at it and I can see a spot where it doesn't go past. Remember, range is how far up and down I can find this function. Well, I'm looking up here. This is super easy. These arrows are going up, so I'm going to positive infinity no matter what. Both sides are going to positive infinity. But on the bottom, this function doesn't pass that point. Going up and down, mind you, right? I don't go any further down than that point. That's the lowest point of this function, which means that when I write my range, I have to use the inequality set. Well, I guess I don't have to, and we'll show you in words what that would look like too. But my lowest point is going to be this value. So 1, 2, 3, 4 down, which means that the lowest part of this function is -4. But it goes up to positive infinity. So I would say it goes from -4. Now, we have to change our sign as well. So far, we've been able to get away with all of our inequality signs just being less than signs. Now, the function touches at -4. It touches -4. So we have to include -4. So now -4 is included, but not include infinity because we can never touch infinity. So I'm going to close my set. That's one way to describe it. You could also say on your set brackets, you could say -4 and all the real numbers greater than that. So all the real numbers including -4 or greater than, and that's why it's close. You can word it all values. It's a little bit wordy, but you could write it that way. All values -4 and greater. And I'll cheat and put a little up arrow for greater because I don't have enough room there. But you could write it out. I'm okay with that. The easiest way, and the way that you should get used to, because you're going to see it most often, is using the inequality notation. So let's do one more quick one, because this video is getting kind of long at this point. So I'm going to shoot through this one rather fast. I'm going to draw some lines. There's some vertical lines. They're not perfect, but they'll work. And I'm noticing that I'm touching more than one time. So it's not passing the vertical line test, so it's not a function. Okay, let's check our domain. Again, our domain is how far left and right this function exists. So I'm looking at these arrows on the left, and they're going on forever. So I know that I'm going to go to -infinity, but on the right, you'll notice that I stop. This function does not go any further than to the right. Again, we're looking at domain, so left and right doesn't go any farther than, looks like, -2. So I'm going to go ahead and make my set notations. I'm going to say it reaches down to -infinity. I could find it over there. Not included. I'm going to use X. And then I'm going to say that, and it does touch -2, so I'm going to include it. It touches -2. And I'm going to say the farthest it goes to the right is -2. I can't find it. So if I plug in 2, there's no function. I'm not going to run into the function. If I plug in 7, I'm not going to run into the function. The last point I can plug in and hit the function on my domain is -2. So let's do the range. In the range, you'll notice that this arrow is going down. So it's going to go down to -infinity. And this arrow is going up as well to the side. So it's going to positive infinity. So this is going to be all real numbers. All right, so since the video is getting kind of long, and I think we reviewed enough at that point, I'm going to pause and stop and say, good luck. If you have any questions,